Hello everyone, it's NetworkBret. Today I'm learning more about IPv6 essentials. So this is a great book. I'm basically doing a summary to try to explain it a little more simply. These books, they're very verbose. You don't really need to know everything in it, and I also feel like it helps me to re-explain things. So this is the start of a deep dive on IPv6, and the first chapter is pretty much what I'm summarizing today. So the history of it, all you really need to know, unless you're taking an exam or something, they started developing it in the 1990s. The Internet Engineering Task Force, IETF. There's a lot more details. They looked at some other protocols or whatever, and this is what they settled on. I don't think you really need to know all that. So basically, why IPv6? Well, IP version 4 is running out of space. It's 32 bits, and that format has a theoretical limit of 4.3 billion addresses. Um, Now, at the beginning, some companies were buying like giant address spaces. They didn't really think that they would run out, so they're giving companies, I don't know what they were selling them for, like price wise, but they were giving them too many address spaces. So a company might have bought, millions of addresses, and they don't really need that many. But even if they didn't do that, the fact that the address space has 4.3 billion addresses kind of creates this problem because you don't just have one IP address at your house. You typically have a laptop, a phone, maybe some other devices. So even though surely not every person on Earth, not 7 or 8 billion people, they don't all use the internet. Um, the people that do typically have more than one device. So, 4.3 billion addresses, especially when you're including some people have work computers, maybe multiple, a work phone and work computer, there's just not enough. IPv6, it has multiple, this is what they said, multiple IP addresses for every grain of sand on the planet with the 128-bit format. Um, it's a different numbering system too. I think it's hexadecimal. I'd have to double check, but it's a different format than just the 32 bits of pure numbers that was IPv4. I'll get into it. I just forgot the name of it, but it has letters in it. Can we just keep IPv4? So there is something called NAT. If you're not too familiar with networking, I'm going to try to summarize it the most simple way possible. It's almost like you use a name at your house, but then you wear a name tag when you go out, and it's a different name. So you can use an address that's used somewhere else. So two people in separate houses can have the same name, but when they go out, they change it to the region or whatever. So my name's Brett. Somebody else's name is Brett. When I go out, I'm Jeremy from Florida. So the other Brett can also be a Jeremy, but he's a Jeremy from Germany or something. So we're both named Brett. When we go on the internet, we're both called Jeremy, but I'm Jeremy from Florida. He's Jeremy from that might not be the best metaphor, but you can reuse public addresses that are used elsewhere, but you use them privately, and your router changes it so when the traffic goes out to the internet, it's something else, and then when it comes back, it just transfers it back into your name. And ISPs do this, they call it carrier grade NAT, network address translation, where they do it on like a completely different scale. Um, NAT is as simple as changing the IP address to a different IP address. Carrier grade NAT is basically like doing that 10 times. So some of the differences between IPv6 and IPv4. I mean, I'm gonna go deep on all these. Um, but the address space is much, much bigger. The IPv6 has auto configuration. They simplify the header, and they also support extensions. So the auto configuration is SLAC, or stateless address auto configuration, and it automatically assigns an IPv6 address. With IPv4, you either have to assign it manually or dynamically with something like DHCP. So yeah, when you turn on IPv6 device, it just boop gives it an address. That might not sound good if you're worried about like maybe security things or something, or you want to be more selective. People are used to using IPv4, so they're used to picking it, which can be a headache as well because if you have IoT devices, like let's say your refrigerator, your microwave, your car connects to the internet, whatever. If you had to assign them all IP addresses, I mean, that could get very confusing. Definitely if you're in, let's say, a warehouse or something where you might have a ton of devices. You have, you know, temperature gauges and other gauges that maybe connect to the internet. Just in theory, it could be a pain if you have to give each one a manual address. IPv6 solves that problem with auto configuration. They simplify the headers. It doesn't sound as simple, but it is simpler. So they fixed the length of the IPv6 header to 40 bytes, where IPv4, I think it was 20 to 60 bytes, but it was variable. So maybe it's 20 this time, maybe it's 30 this time, maybe it's 40 this time. And every time they sent the header, which goes on the packet, the router or whatever had to process what length it is before it processes it. So it kind of had that at the beginning where it was just adding more compute power, where it just kind of made it harder. We're keeping it 40 bytes, it's always the same. So, if you're packing boxes into a truck, it would be pretty easy if they all stack right. Where if you had them all different sizes, that's a little different. Now, funnily enough, while I'm explaining how that is simpler, there's also extensions that can be used with IPv6 where it's added on there, and it's just different how it's set up. But with the introduction of this, they could potentially add new things in the future. So it kind of opens it up where it's more customizable but less overhead at the front end, I guess. So this is the very simple intro to IPv6. Next time I'm going to get more into the addressing scheme. That'll be surely a longer video. This is the main concepts that you need to know for now. And this is going to be a whole series. I'm going to make it into a playlist. And it's going to help me understand IPv6 because, it's coming. Whether or not you like it, it's coming.